right, you guys are ready for Notes 9 now. This one is determining slope and y-intercept. Investigating slope and y-intercept. The graph of every non-vertical line crosses the y-axis. Let's think about what that means. Let's pretend this is a real quick mini graph of the x and y-axis. If it is a vertical line, vertical means going up and down, so let's say this is my line. It's never going to touch my y-axis, is it? Here's the y-axis, but if it continues to go up straight that direction and down straight this direction, it's never going to lean over and cross. However, every single non-vertical line, so if it's non-vertical, even if it looks like it's only slightly tilted, at some point way down the line, it will end up crossing my y-axis. So the graph of every non-vertical line, if it's non-vertical, it will eventually cross the y-axis somewhere. That is called the y-intercept. And just think of it, you guys who play football, it makes sense. It's the point that my line actually intercepts the y-axis. So at some point, this line will intercept the y-axis. And that point that it touches the y-axis is called the y-intercept. That is a huge vocabulary term that you're going to hear the rest of your math life, especially into high school. So please understand that the y-intercept is the point that my line touches the y-axis. And when it does that, the y-coordinate would be where it touches the y-axis at, and the x-coordinate would be 0. And that makes sense because let's look at one more little graph up here. If my line looked like this, it would touch the y-axis at, let's just say that that's -2. So it would intercept my y-axis at -2, and that coordinate, the x-coordinate would be 0, because read what this coordinate would be. Let's say that's -2. It would be at 0, -2, because you'd go left or right 0, but down 2. So every time you're looking at what the y-intercept is, it is the point where your x-coordinate is 0. It's whatever your y-coordinate is. Okay, so now we get to our big overarching equation, y equals mx plus b. This is written in big, bold letters because you need to know it. Slope-intercept form. Anytime we say this is an equation in slope-intercept form, this is what we're talking about. So in this equation, y equals mx plus b, m is going to be your slope, and b is going to be your y-intercept. It is huge that you guys understand what this is. And when I say m is your slope and b is your y-intercept, it means that the m is going to actually be changed out and it's going to be a number, and the b is actually going to be changed out and it's going to be a number. So you might have something like y equals 7x plus 4. Or you might have something like y equals -12x minus 2. And it's very important that these aren't just random equations. What it represents is 7 is going to be how steep the slope is in this line, and 4 is going to be the place where it intercepts the y-axis. So in this situation, -12x would be your slope going downhill, and -2 is going to be where it hits the y-axis. So again, these are going to be switched out for numbers, but these numbers are going to be like a code for you. They're going to represent what the line is going to look like on a graph, depending on what the slope is and where it hits our y-axis. All right, a linear, there should be a little bit of a space there, but that's okay. A linear relationship has a constant rate of change. We've talked about constants a lot. And if it's linear, if it's a straight line on a graph, it has a constant rate of change. You can find the rate of change, which is your m, and the initial value b for a linear situation from a set of tables, and this is from a table of values. Okay, so here's your first example. A phone salesman is paid a minimum weekly salary and a commission for each phone sold, as shown in the table. Here's our table over here. Confirm that the relationship is linear and give the constant rate of change in the initial value. And again, constant rate of change is going to be our slope, or our m, And the initial value, so how much we started with, that is going to be our y-intercept, which is also going to be our b. Okay, so they've kind of done the math for us. They've said, okay, from 480 to 630, it's a difference of 150. And they've said from 20 to 10, from 10 to 20 technically, that is a change of 10. So they've put the 150, which is your y, over the 10, which is your x, and if we just divided that out with a calculator, 150 divided by 10 is 15. All right, then they went, well, how much is it from 630 to 780? And they subtracted that out for us and got 150 again. Per 20 to 30 is a change of 10. So they've done all that work for us too. So 150 over 10 is once again 15. And then in the last one, they went, okay, how much is it from 780 to 930? That's a difference of 150. And how much is it from 30 to 40? That's a difference of 10 also. So 150 per 10 is once again 15. So the rate of change is 15. Now, what we need to do, now that we know it's constant, and we know our 15 is our rate of change, so that's going to be our slope, so our m. So if we went back to this formula, y equals mx plus b, we know part of it. We know what our m is going to be. It's going to be 15. So we know half of our equation. We have y equals 15x. Now we need to figure out what the b is going to be, what the y-intercept is, and that is the initial value when the number of phones sold is 0. And again, the reason it's when the number of phones sold is 0 is because wherever our y-intercept is, our x value is going to be 0. So we basically need to make our x value 0. This is our x, this is our y. We need to make our x value 0 and see what that y value is. And whatever it is, when x is 0, your y value is your y-intercept, or your b. All right, so they went back to this table and went, well, it's real easy for me to find when x is 0 because I can just do 40, 30, 20, 10, and 0. And I can just work myself backwards. And if I know I'm going down by 150, 150, 150, I can just subtract another 150 and see what y is when x is 0. And that's exactly the math they have done for us here. They went backwards by 10 to get 0, and they went backwards by 150 to get 330. So 330 is our b, or our y-intercept. So if we put it all together in our equation up here, we would have y equals 15x plus, because it's not a negative 330. If it was a negative 330, it would be minus. But since it's plus, we'll put plus. Since it's positive, we'll put plus 330. So in this phone situation, our equation is y equals 15x plus 330. And I need you guys to know that 15 is the slope, 330 is the y-intercept. So this is kind of a code to tell you the situation and kind of to tell you what it would look like on a graph. On a graph, we would start at the y-intercept, which would be way up here. Pretend there's hundreds of little dashes here. Our y-intercept would be at 330. And then our line would go up 15 per every one. So it'd be very steep. But you could picture it on a graph if you can get your information into an equation. All right, you guys are going to now try the your turn. So find the change in y's over the change in x's. Remember, you flip it, and that's going to be your slope. And then work yourself backwards to find when x is 0, what y would be in order to find your y-intercept. Give it a try and then turn back on the video to check. Okay, so the change in y's from 22 to 32 is 10 per 2. Just to double check, we really kind of need to do a few more. So 10 per 2 there also, and 10 per 2 there also. So remember, to get your y's over your x's, flip it, and 10 per 2 is the same thing as 5 per 1, or just 5. So we know that our slope is 5. That's our constant rate of change. Now we need to find the y-intercept. The y-intercept, I'm just going to abbreviate it y-int, is represented by whenever x is 0, what would y be? So let's just work backwards. If we were at 8, 6, 4, 2. Skipping by 2 more would get us to 0. And if we're going down by 10, 10, 10, it would be 10 more to get to our y-intercept. So 12 minus 10, or sorry, 22 minus 10 is 12. So our slope is 5, and our y-intercept would be 12. Now it doesn't tell you to do this, but I'm going to have you guys write an equation too, because now that we know that y equals mx plus b is your equation, and m is your slope, and b is your y-intercept, and I gave you just now what your slope and y-intercept are, you should be able to write it into an equation. So real quick, even though you probably don't have this in the your turn part, go ahead and write that y would equal 5x plus 12. So that's your final equation. All you do is make the m your slope, make the b your y-intercept, and you've written an equation. All right, check number 2. So from 8 to 15, that's increasing by 7. 15 to 22, 7. 22 to 29, 7. From 1 to 2 is 1, 1, 1. So if you flip it and put the y's over the x's, that's 7 per 1, or just 7. So that is your constant rate, which means that is your slope. Slope is 7. And then what is the y-intercept? It's the x, when the x is 0, what the y value is. So if we're going 4, 3, 2, 1, 0, 29, 22, 15, 8, go back 7 more, and you'd be at 1. So the y-intercept is 1. Let's try to go ahead and put it all together in an equation. Your equation would be y equals slope, which is 7x, plus your y-intercept. And in this case, it's a positive 1, so it's going to be plus 1. All right, page 2. Oh, nothing. You guys are ready for teacher talk. All right, good luck.